All right, so welcome. My name is Richard Stager. I am with Ingevity, and it's my privilege today to introduce to you John Garrity. And John is the Minnesota DOT Bituminous Engineer, and he is a registered engineer in the state of Minnesota. He's worked at MnDOT for 37 years, and most of that time he's been in the bituminous office. During his time in the bituminous unit, he's helped develop quality management specifications, including contractor mix design and technician certification requirements. He's implemented the performance graded asphalt specifications and super paved mix design within the department. And he's continued to improve Minnesota's asphalt pavements by analyzing new technologies such as Super Pave 5, SMAs, spray pavers, longitudinal joint treatments, and most importantly today, the use of Warm Mix Asphalt. If you have questions during this presentation today, please use the Q&A function and we'll try to address those at the end of the presentation. Also, this event's being recorded and we will email this out to all the attendees, and this will also be available. You can forward that to people that are not able to attend in person today. Also, Ingevity will post this to the Ingevity YouTube and also the Ingevity website. And then finally, it will also go out on social media. So if you missed that, or somebody that you know is interested in this topic, we will have that available. So with that, John, I'll turn it over to you. Thank you.
Okay, thanks. Did that come up, Richard?
I can see it, yes.
Okay, perfect. Thanks. Okay, well, thanks, Richard, and good morning, everybody. First of all, I'd really like to thank Ingevity and especially Craig Reynolds for inviting me here today. And I'm really excited to tell you about what we've been doing in Minnesota this past summer. We implemented a Warm Mix Asphalt specification that included incentives. So that's kind of what I'm here to talk about today. If I can get my slides moving here. Okay, and so what I thought I would do, we really kind of have to build up to the reason why we went to a provision with incentives. So I figured it might be best to look a little bit at the warm mix history in Minnesota and then our specification development. We did have 4 warm mix jobs this past summer. We'll talk about those, and then we'll also look at what we're going to do in the future here. So our Warm Mix Asphalt, we'll just kind of run through these and then we'll look at them more closely after this slide. But Warm Mix really started in 2007 in Minnesota. We had a couple of jobs on county projects. In 2008, we did some Warm Mix at our Min Road facility. In 2009, we had a late fall paving project that we decided to include Warm Mix on as kind of a compaction aid, but it was interesting to apply it in that respect. In 2010, we had 2 projects in our MnDOT District 3, which is just a little bit north of the Minneapolis, St. Paul metro area. In 2014, we included a permissive specification in our standard bituminous specification. And then most recently, in 2025, we developed a Warm Mix Asphalt option with an incentive payment. All right, looking at, kind of going back in time here at some of the first projects we did. Again, those were back in 2007, and they were actually in southern Minnesota on that star you can see there. And that's down towards Rochester, the Mayo Clinic area down there. But the counties were pretty progressive down there, and they decided that this might be a good time to try Warm Mix Asphalt. So the product that they were using was the Revix technology, and that was that technology that was developed by Jerry Ranke from Matthey and Galen Baumgartner from Paragon, and that eventually became the Evotherm 3G. And I should probably mention these projects down in southern Minnesota. It was indeed Matthey Kathy, who did the paving on those. But one of them was a county road, and that was a 5-mile stretch. And then the other one was a county state aid highway, and we placed 537 tons on that project. And both of those projects went well. So in 2008, we decided to construct some of the cells out at the MnRoad test facility using mainline. And just to kind of give you a little bit of reference here, what we're looking at on the left-hand side of the picture, this loop, that's the low volume loop. And the truck just drives on one side of the road and the other side is just left to see the environmental impact. To the right of that, where you see all of the cars, that's actually westbound 94. And that's the those are the test cells. And if we actually move to the right of that, you can see the I-94 lane there with no traffic. That was the original build on that project. And so they've been alternating traffic between the original build and the test cell section. And then on the furthest right side, they have the eastbound traffic. And I should mention that right now that they're currently in the middle of a construction project that the roadway currently has 2 lanes to it, and they're making it a 3-lane highway out there. But so that just gives you a little bit of perspective on the MnRoad facility. But what we did back in 2008 was we did construct 6 cells on mainline. And again, we used the Revix product on these, and we included Warm Mix in all layers, the wear and the non-wear. It was a 12.5 millimeter size mix. The traffic levels out in this area are between 3 and 10 million easel. And then we had a PG 58-34, and we did include wrap in the mixture. All right, moving to 2009. This is that late fall project I was talking about. This was actually in the Minneapolis-St. Paul metro area, late fall paving job. The contractor needed to get it completed before winter, and there were some delays. And this was at a time when we were hearing, quite a bit about the improvements that Warm Mix could give in terms of being a compaction aid out on the project. And we thought this would be a good opportunity to give it that try. So we wrote a supplemental agreement up. At the time, we paid 60 cents per ton to add the Warm Mix additive. And what was really kind of curious on this job, though, was I think the contractor took to heart that the Warm Mix was going to act as a compaction aid. So they kind of changed their rolling operations. They actually pulled one roller off and went at it with kind of a lesser rolling train that they had been using with the hot mix asphalt. And so the first day of Warm Mix paving in regard to density didn't work out that well, but they quickly discovered that they should go back to the same rolling train. So after that little mishap the first day, from there on, everything went well in regard to placing the mix as well as compacting it. Now, in 2010, we actually developed a provision that was included in the contract when the contractor bid on the projects. And this was north of the city, is about an hour and a half. And the provision that we had put together was at the time we were really referencing everything that the federal highway had done. And we mentioned that the contractor should just design the mix as they would under normal hot mix design criteria, but then include that warm mix to see if that affected any of the properties, and that was what the approval was based off of, was the mix with the warm mix additive in it. And at the time we were referencing again the federal highway. I think that was this highlighted website. I think that was the federal highways, the warmmixasphalt.com. But also at that time, and some of you might remember well, even in your states, that the use of shingles was quite large at the time. And because this was a new thing for us to try, we thought, well, let's exclude recycled asphalt shingles from the mix. But so we didn't allow shingles. We did have wrap in the mixes. And the one thing that we did do, which we didn't follow with future specifications, was we put that the contractor had to produce mix at 275 degrees Fahrenheit or less. And that was kind of a restriction that really at times can paint a contractor into a corner. This was at the time, back in 2010, it was just like everybody and their brother was had some type of warm mix additive. This was a federal highway slide. I think Matt Corrigan and Dave Newcomb had put it together, but I don't even think this is all of the products that were available. But at the time when we did let that project, we said just go to the federal highway site. Anything that was on their list would be an approved product that they could use in the mixture, whether it was an additive or a physical method. And so in 2014, just kind of based off of that experience that we had developed from the projects previous to that, we did include a permissive spec or a permissive provision in our bituminous specification. So we said warm mix asphalt is an approved alternate to hot mix asphalt. And at the time, there were quite a few of the foaming systems out there. So we said warm mix can be manufactured through the use of foamed asphalt or a chemical additive process. The one thing that we really needed to know at MnDOT for our laboratory compaction was the lab compaction temperatures. So the contractor and the agency had to make sure that they were both compacting in the lab at the same temperature, so that wouldn't affect the mixture properties in a way that would have been from compacting at different temperatures. All right, then let's jump up to 2024. And I was at a project engineer meeting, and I was talking with one of our assistant commissioners. And this was at a time when kind of the soup du jour was low carbon transportation materials and carbon reduction methods. And we were kind of talking about that. And he happened to ask me, how much warm mix are we using in Minnesota? And I kind of gave him the timeline that we had just talked about on those previous slides there. And I mentioned that back in 2014, we had included a permissive specification in our specification. And his question was, okay, how many warm mix projects have we done? And I said, well, I think I could probably count them on one hand. And kind of in the same breath, he said, well, why so few? And I said, well, that provision is permissive. However, we did not include a pay item for it. And so I said, my guess is that the contractors just don't want to pay the additional money to include the warm mix additive. So he said, well, how could we promote or increase the use of warm mix? And I said, well, an easy way would be to just put a pay item in for the warm mix. And he was thinking a little bit, and he thought, well, how about if we went with an incentive? And I said that would work equally well and might be a better way to do it. So with his direction, he said, okay, see what you can come up with for a provision that allows the use of warm mix and will pay an incentive for its use. So in the bituminous office, we came up with a provision that actually it's an option. When it's included in the contract, the contractor can decide whether they want to use warm mix or not. So that was kind of an interesting way to include it, we thought, not forcing the contractor to do it. But then again, we included the incentive along with that. And so we tried to keep it short and sweet. And on the screen here is the entire provision. And, I don't expect you to read everything. So we'll just pull out some of probably the more relevant or pertinent points from this provision. And one of those, again, first off, it is an option when it's included in the contract. It's an option for the contractor to use it. They're not required to use it. And then we define warm mix as any mix that's produced at a temperature of 275 degrees or less. And up in Minnesota, because we have the cold weather, we said we don't want a wax chemical. And then in terms of measuring the temperature, we measure the temperature as it exits the drum. Now, many of you are aware that typically with an asphalt plant in the morning, we have to kind of get the cobwebs out and get the iron warm. And so we decided to include in this provision that first 100 tons of production in the day, the contractor could produce at hot mix temperatures to get the bag house warmed up and get all of the other equipment running well. And we felt it would be most fair at that time to then include that 100 tons in the inclusion of the incentive if the contractor was making the warm mix. We felt that just because of the operations of the plant where they really needed to start the morning at hot mix temperatures, we felt that that was something that they couldn't work around. So we thought that was fairest. And then we, on our plants in Minnesota, we require that the plant reports every 20 minutes different information such as the cold feed rates and proportions, the added asphalt cement, as well as the mixed temperature. So we said that we would grab those mixed temperatures from that recordation system that's printing every 20 minutes. And then we were afraid that, okay, what if somebody starts spiking results, just to get that average where it is. So we did put kind of a clause in there that no incentive payment would be paid if more than 10% of the daily discharge temps were above 275 degrees. And then probably our biggest concern, density is probably that single item that has one of the biggest impacts on long-term performance and durability. So we didn't want to, gain one aspect at the expense of another, and that being density. So we said we also included in the provision that no incentive would be paid out if greater than 25% of all density lots for the project failed to meet the minimum density requirements. And so this is the pay table that we use then. Again, warm mix is considered anything below 275 degrees. So the contractor can produce mix at temperatures above 275, but they just wouldn't be able to get any of the incentive. And as you'd expect, the incentive actually gets higher as the mix temperature goes lower. And so this past summer, again, we had an exciting year. We had 4 projects in the state that included this provision. The first project, let's look at that pin up on the top of the map. That was in our District 1, that's north of Duluth that we're looking at there. And that was on our Highway 73. And that project was almost 80,000 tons. And that actually had high RAM in it as well. And then if we go straight down from that pin to the Highway 14 project, that was an urban project. That was actually in the city of Rochester again. And that was roughly 14,000 tons. And then if we go to the west of that in our Mankato district, that Highway 60 was roughly about 50,000 tons, and the Highway 22 was to get projects everywhere in the state. We didn't get anything in the center, but this summer I think we'll be able to do that. But so we felt we had a good spread anyway. And this is our warm mix summary from those paving jobs. And the things that we thought that would be interesting to look at, first of all, was, okay, how much of the possible incentive was earned on these projects? And then again, our concern was, we were really supportive of using the warm mix, but we didn't want to compromise density on the project. So we really wanted to look at those two things as well as the mixing temperature, the possible incentive earned, the mixing temperature, and what the density was out on the project. So on that Highway 73 project that had 80,000 tons, the contractor got about 52% of the maximum possible incentive. The average mix or plant temperature was roughly around 255 degrees. And you can see they did quite well on the density values. In Minnesota, we have mat density requirement as well as longitudinal joint density where we're cutting cores. On the Highway 60 project, the contractor was able to get about 65% of the maximum possible incentive. And on that project, we see two different divisions in the mix there. They had both wear and non-wear mix on that project, but the plant mixing temperature averaged at about 260 degrees, and you can see that the densities were quite well on that. That was actually a mix for a high volume roadway, so there was quite a bit of crush in that, and I think the FAA was either 44 or 45. So it was a mix that had quite a bit of crush in it, so a little bit more difficult to get density on. The Highway 14 project, the contractor was able to get about 70% of the maximum possible incentive. The mixing temperatures for that were, as you can see, about 255 degrees, and they also did well on the density. On that Highway 22 project, you can see that one actually worked out the best in terms of the maximum possible incentive earned by the contractor at about 90%. And they were producing at the lowest temperature, roughly about 240 degrees. And interestingly enough, look at the densities on that, they actually had the highest mat densities as well as the highest longitudinal joint densities. So all in all, we were really happy with the results from those 4 projects that we had this past summer. Now, in our office, we developed a spreadsheet an Excel spreadsheet that we figured would help out in the field determining what the incentive was for the day. So there was some logic built into it. You just had to enter the information from the 20-minute recordation, and it would look to evaluate whether there was a violation of the, spiking the results for the day. And so it really worked out fairly clean in the sense of just being able to enter the data, and the spreadsheet would provide you with what that incentive was for the day. So that worked out well, and the contractors seemed quite receptive to that as well. Now, after the projects were completed, we thought, okay, it would be a good time to call the contractors and just kind of do a little follow-up on the project. So starting with that Trunk Highway 14, now this was that project in Rochester. It was an urban project, and this was a permanent plant setup where the contractor was producing both warm mix and hot mix at the same time. So logistically, that was a little bit of a trouble for the contractor. They said that it wasn't as clean as if they had been able to just produce the one mix, but they were able to work through producing both the warm mix as well as the hot mix at the same time. And overall, they said they were satisfied with how the project went, and they would be interested in pursuing it on other projects as well. Trunk Highway 22, if you recall, this is the project where we had the lowest production temperatures, and the contractor again had a really good run on that project. The temperatures were below 240, great densities were achieved, no major struggles. They did say that in areas that did require some handwork, it was a little bit of a challenge. Now, there wasn't much handwork. This was just kind of a rural tangent section that they were working on, so there wasn't much handwork, but where they did do some of these, said it was a little bit more difficult. Trunk Highway 73, now that was the project that included the high ram, and that's a project that was about 80,000 tons. And overall, the contractor thought the project went great, or real well. And it was interesting, the last 2 days of production, they decided to go to the lowest temperatures, or I mean lower than they had previously been producing at. And they actually found that they were able to get better densities at lower temperatures. And that kind of goes hand in hand with that Highway 22 project that we were looking at previously, where they had actually the best densities on the project. So that was just interesting to note that actually the lower the temperature was, they actually did get better densities. And then the contractor said they thought it was easier on the bag house, and the lab equipment seemed a lot cleaner. Now, the Highway 60 project, the contractor said they thought it was a good finished project or product. And again, this was the project that had the mix with quite a bit of coarse and fine aggregate crushing in it, and they did struggle with density a little bit on there. They had quite a bit of quartzite in the mix, and they said they said it was tough to compact, but and that could have been from the mix design itself. Probably some changes could have been made to that, but all in all, they thought production at the plant went well. Now, here was from that Trunk Highway 73 project, that 80,000 ton project. And starting with the pictures up on the top left there, funny enough, this plant setup was kind of in a hole, and probably 5 days before the project was to begin, we got about 5 or 6 inches of rain, and everything we're looking at there looked like a lake. The contractor walking through there with the water was up to about their knees, and so we had to first of all get rid of all the water from the plant site. But once we did that, everything worked well, and we didn't have any more rain the rest of the summer. Now, on the photo below, again, this was high wrap or high ram as well as warm mix asphalt, and you can see we've got the totes of the Evotherm there. And I guess I forgot to mention, actually, just coincidentally, all 4 projects that we had actually used the Ingevity Evotherm product. And so on this photo here, we're looking at the totes of the Evotherm, and then the high wrap or high ram additive was actually being added at the manufacturer at the terminal. So the asphalt loads came with that already pre-blended into it. Now, the center photo there shows we had the crew out on the project that day, and I want to point out Craig Reynolds in the back there, second from the left. I really have to give kudos to Craig. I think he and I probably talked every week this past summer. We met up on every warm mix job, and he just did a great job in really making it as seamless as possible for our first year, incorporating a warm mix provision. And so things really went well, and I think we owe a lot to Craig for helping us get through there. But on the right-hand side, again, the density results that we were looking at earlier, all of the projects really had great density. And again, funny enough, when the temperatures were lower there, we're actually getting better densities. And so when we look at the potential benefits of warm mix, we've got the environmental, the operational, and the performance. The environmental, we're looking at reducing our greenhouse gas emissions. Just the other day here in Minnesota, we had a towards zero seminar at one of the hotels, and we had a great complement of people from all the discipline areas attending. So just looking at reducing the emissions, so the environmental aspect, the operational, the people working around the material, it's just more comfortable working conditions, and again, we saw good compaction on those projects as well. And the thing that I look at, though, is the performance. In Minnesota, on our new construction projects, we typically are using the -34 grade to help us minimize the potential for thermal cracking. And looking at, if we think about if we're producing mix at a lower temperature, it's just going to improve the performance of the mix that much more. We're reducing the potential for oxidation or aging going through the plant. So I think, if you look at all of the different aspects, the environmental, the operational, operational and the performance. I think it's really a win-win for everybody, you know, contractor as well as the owner and as well as the public in general. So I think we're really just again excited and happy that we do have this provision out there now, and excited enough that we've really got a big season coming next year, 2026. We've got 10 projects already lined up, and I think we might have found another one yesterday. But as you can see up in the Duluth district, again, we do have another project that's going to include the provision for warm mix, but it also is going to have the high RAM provision in it as well. So we just we're happy moving forward the way we are, and we think we're going to get great benefits out of it. And so we're just kind of excited that the paving has kind of turned this direction. So with that, I want to thank you. And are there any questions?
Hey, John. Yeah, we've got a few questions in the Q&A as well as in the chat. So if you do have questions, if you would please use the Q&A function. We'll try to get to those. So let me start at the top here. I have a question from John where he asks, how do you prevent a contractor from artificially making the HMA high so that they can get more money back from the incentive? And I assume that means HMA higher temperature.
Yeah, and that's a good question, and that's why we included this in the provision to. So what we do is on that spreadsheet that I mentioned. Okay, that has some logic in it. So it's looking at the mixing temperatures, and if it finds out that more than 10% of the daily discharge temperatures are above 275, then they're not they cannot get the incentive. I should have put that as a or I guess it does say no incentive payment if more than 10% of the temps are above 275. So we think we think we were able to prevent that through that. So I hope that answered the question.
I think so, yes. Let's move on to the next question from David. In Minnesota, are contractors adding the compaction aids or warm mix additives at their own plants? And he goes on to say, in Florida, we have terminal blending of these additives only. It's surprising to hear the best densities being achieved at the lowest temperatures that one company had attempted, which you mentioned, which was on slide 19.
Yeah, and that on all of the projects that we had this summer, and our provision does allow the addition to be either at the plant site or at the manufacturer. And I think in all of our cases, the contractor just opted to add it at the plant site on their own. However, that as I mentioned, that high RAP or high RAM additive, the EvoFlex, was being added at the terminal. But and what was the other part of that, Richard?
He was questioning about, it's surprising to hear that the best densities were achieved at the lowest temperatures.
Yeah, you know, and I was surprised about that, and you know, in fact, that was one of the things I gave Craig Reynolds a call from Ingevity on. I gave him a call and I said, Craig, contractors actually getting better densities with the mixing temperature down, and Craig said that is indeed true. I'm not sure if you can get on or not, Craig, and mention that or if that's appropriate or not. But yeah, I did question that, and talking with Craig, he said that the kind of the chemistry of the warm mix additive did indeed you know, make it work well at cooler temperatures.
Yes,
So,
I can
Craig,
jump on real quick. Yes, I mean, John and I talked about that, and obviously Evotherm is a compaction aid, and it does help achieve density at lower temperatures. And we just throughout all the projects we saw that, but it was nice to see, particularly the one running at 239 was the best. And it was really exciting to see because a lot of states and a lot of agencies are looking at longitudinal joints, and we actually achieved, like, I think it was 93 or 94 on the joint with the 239 degrees. So it's something to keep in mind.
All right, thanks, Craig. David, hopefully we got your questions answered there. We'll move on to another question from Chang, and he asks, how were the temperatures measured and verified for the warm mix projects in 2025? What was the frequency of measurement?
We didn't have a real systematic method, and that was one of our concerns. So that's really a valid question. The hot mix plant is providing a temperature at the discharge, but our concern was how accurate is that temperature. So just thinking back to that picture where we were all sitting at the plant site there, that was one of the first projects we started. And what they ended up doing there was they had a couple of people with temperature guns who would actually go to the discharge site, because that's about waist high there. So they were able to shoot the mix with their temperature guns, and they did validate that with the temperature that was reading out in the plant site. So it wasn't really a real scientific way to do it, but we felt that at the time, we didn't really know what else to do at that point. So we thought that made the most sense. We had verified the temperatures on the temperature guns, and then we had two different temperature guns shooting the mix and comparing that to the temperature that was coming out on the display. And I don't think there were any instances where the temperatures were different in the sense that we couldn't use that recordation system temperature. So, but that probably, and like I said, that's a good point to bring up. Probably if any area maybe should be revisited a little bit, is just to kind of revalidate whether we are indeed getting the correct temperature there. But yeah, thanks.
One thing I would add to that, Chang, is that we had a webinar last October on a system that has been developed to actually do that temperature measurement more accurately and continuously. So if you're interested in that's a system that's put out by Highway Data Systems out of Austin, Texas. Those guys have a really good system. We've got that webinar that's out there if you want to take a look at that. Also, moving on to the next question from Frank. He's asking about the high RAM, the recycled material, or was it recycled asphalt material or recycled aggregate material, and how high?
Okay, good question. It was just recycled asphalt pavement, and it was from the project. And the contractor was running at about 37% RAP. So I mean, we weren't real high, but it was higher than what we would normally do in Minnesota. So.
Okay. Very good. Let's see. I had one question I was going to ask. What's been your feedback from the contractors on this incentive specification?
I think they're really in favor of it. It kind of makes a level playing field, and I guess I've just heard positive comments from them. We actually had 5 projects that were let last summer with that provision in it, and we had one that did not opt to go for the warm mix, but that was a very small project. So I think that contractors definitely are in favor of it, and again, we think it's working well also. So we will continue with the incentive.
Hey, Richard, can I jump on real quick?
Sure.
And so, like John mentioned, we were in constant communication last summer, and he made sure we were all on each job site and talking to the contractors throughout the year. And one of the greatest things about the spec that we ended up taking out to the producers is they can look at their data at the end of the day and know if they got the incentive or not have to wait for weeks or months. So everybody I talked to was extremely pleased with it because it was instant gratification. You could know where you were at today and what you had to do tomorrow and not have to wait.
Okay, well, that's good. Thanks, Craig. Thanks for that feedback on that. One other question that I had, John, was that I think you mentioned early on in the presentation that that there was the laboratories, the contractor, and the agency were trying to compact mixes at the same temperatures when you use the warm mix additives. Can you elaborate on how you went about selecting those temperatures? Or did the contractors just pick a temperature they decide they're going to run at?
You know, I think that was actually working closely with Ingevity on that. I think Craig was a part of that discussion. And you know, I don't know what the mixing or what the laboratory compaction temperatures were, Richard. And yeah, I don't know if Craig, if you recall what was the basis for that laboratory mixing and compaction temperature?
A lot of them started off right around targeting 260 just to keep it below that 275. And then I think some of them were presenting to MnDOT to go down to that 240 number once they got comfortable with it. And they were just essentially sharing what they were doing out in the field to make sure that when MnDOT brought it back to the central lab that they were compacting at the same temperature.
Okay, very good. Got a few more questions coming in on the Q&A line here. Frank is asking, what was the percent of Evotherm used in the oil or the asphalt?
Craig, I guess I don't remember what the percentage was.
It varied, obviously a couple different jobs and a couple different types of oil and projects, but it was in between 4/10 and 5/10 of total AC.
For the additive, it was.
Yep.
What was the additive?
The Evotherm, they were dosing it at 4/10 to 5/10 of total AC.
Okay, very good. Yes. Another question from David asks, if a DOT representative suggests that contractors already benefit financially from reduced production energy costs when using warm mix asphalt, how would you recommend addressing the rationale for offering an additional incentive? And then he adds, thank you for this presentation.
Oh, well, thank you. And a great question. And I think that would come to the performance benefit. You know, going through the plant we have reduced aging, so we should see reduced cracking on the pavement. So I think that would be the, you know, any way that we can minimize the intrusion or infiltration of air and water, and you know, I think that's a benefit, and to our pavement structure, you know, long-term performance and durability. And I think that we're able to improve the cracking characteristics through this reduced mixing temperature.
Okay, thank you. Still a couple more questions coming in, John. This is a question from Deb, and he asks, can you please comment on the scope of using RAS with reduced temperature warm mix? Have you tried it at all?
We did do that highways, or sorry, Richard, was it RAS?
RAS is
okay.
Is what he wrote, yes.
I have not seen RAS used in Minnesota for over 15 years. I think the supply dried up. I guess I can't really answer that. I just don't know.
Okay, no, that's fair.
Yeah.
Then he has another question, and he has a comment on this, and I do know Deb. Deb and I've worked together in the past when he was in Oklahoma. So his comment here is that in our field trial effort, which is a low carbon transportation materials project in Oklahoma, we also saw better, although very small amount, density levels for reduced temperature chemical warm mix in comparison to the hot mix. And he added that they produced at around 250 degrees Fahrenheit. So I think that's just adding to the some of the questions you got earlier that, how did they get better densities when they were producing at lower temperatures?
Right.
So just a little follow on to that. So with that, I think I've got most of the questions. I think there was a couple in the chat. I think there was one question in the chat that asked about what kind of warm mix technology did you use? I think you answered that. It was mostly Evotherm, I suspect.
Yeah, all of the 4 projects we had this summer, I'll use the Ingevity Evotherm technology.
Okay. So with that, we can take a few more questions if there's any more out there. We'll give a minute or so. I may have. Oh, I was going to ask John on that project. I think it was the Trunk Highway 73 project. What time of year was that produced?
That 80,000 tons, they had some grading on the project. So the grading started, I believe it was right around the 1st of June. And they ended up paving into September. So that's actually a great question, Richard, because they did in northern Minnesota in September, we actually did have some mornings that were at right around 32 degrees. But the majority of the project was during the summer months, but they did go into September and they did have some cold days there. But and with that cold weather, that was I made a call immediately to the contractor who I know well, and I said, how did compaction work? And in terms of the rubber tire roller too, was any issues with mix pickup on the rubber tire roller? And they said that they didn't see any issues with it. Now the typical in Minnesota, sometimes that cold weather can be short-lived, and we just had it for a few days, those real cool mornings. Then after that, it warmed up. But I was curious how it would work at those cooler temperatures, and that was about the coldest that we did go, or those mornings where it was right around 32 degrees.
Okay, very good. Well, I think that's all the questions we have for now. And so if you do have more questions or want to comment on this, please reach out to us. As I mentioned at the beginning, we will email out to all the attendees a link to the recording, and Ingevity will post this on the Ingevity YouTube site as well as Ingevity's website, and then our communications group will make this available on social media as well. So with that, John, I very much appreciate your time and effort today for presenting this information. Thanks, Craig, for answering some of those questions with us. And with that, I wish you all a good day. Thanks for attending.
Thank you. Bye.